that would help. And if you move closer to the middle of the row, that would actually free up the seats at the ends, and those will be easier to find. So thank you very much for your cooperation. And good afternoon, everyone. Thank you very much for your cooperation. Got off to a little bit of a late start, but welcome to the final planetarium show of the day. This is our tour of the universe. How many of you have seen our other shows today, either Living Worlds or Expedition Reef? A few of you, okay. This show's a little bit different. This show isn't completely live. And what it means is we're flying through a virtual 3D model of the entire universe. So we're going to leave Earth behind, fly through our solar system, leave the galaxy, go out to the edge of the visible universe, and come back by 5 o'clock. Now, we're going to do that using a piece of software sponsored by NASA, supported by NASA, and it's something that you can actually download for free to load up on your computer at home. So if you like what you see here on the dome overhead, come and see me at the end of the show, and I'll tell you how you can get the software for free. During the presentation, since it does involve live flight through virtual space, one thing that might be a little disconcerting to some people is the illusion of motion across the dome. And here under the planetarium dome, it's a very immersive sensation. If you find that illusion of motion is a little too convincing, just close your eyes for a minute or so, and that should help. You'll find yourself back on planet Earth. I will try not to fly into any black holes or crash into any stars, but that's something that's good to keep in mind. Now, during the presentation, as always, we'd appreciate it very much if you could please refrain from eating, drinking, smoking, snacking, or any kind of photography or recording. This is also a great time to silence your personal electronics and turn off any light-emitting devices such as cell phones, cameras, tablets, etc. At the end of the show, we ask that everyone please exit out through the doors at the top of either stairway. If getting up these stairs is a problem for any of you, just stay in your seat at the end and our staff will assist you out the lower exits if that's more convenient. But with that, okay, looks like everybody's ready. Turn off those cell phones. And let's get ready to travel off into outer space. Now, we're going to start off at one particular location here on Earth, kind of an unusual one. So I'm going to turn off the lights. And see if you can figure out where we are. Right here. What is this? We are 1 kilometer, roughly, above the ground, over the Ouarzazate solar farm in Morocco. This is the world's largest concentrated solar farm. About 6 times the size of Golden Gate Park. So about 6,000 acres. And it's huge, as you can see. We're traveling up now. We're about 7 kilometers up. And we're going to keep on going. In the words of one famous astronomer, outer space is not that far away. It's only an hour's drive if you could drive straight up. And we're going to go about 100 kilometers to the edge of space. So this is the officially recognized boundary of outer space, 100 kilometers, or about 62 miles, roughly the distance from San Francisco to San Jose or Santa Rosa. And this is the edge of space. Why is it the edge of space? That's because the air is so thin up here that air control surfaces like wings, rudders, flaps don't work. You need to use rockets to maneuver around at this altitude where the air is that thin. So this is the official boundary of space, but to go to where people are right now in outer space, living on board the International Space Station, we have to go about 4 times this height, about 400 kilometers to about here. And this is the altitude of about 230, 250 miles. And this is where the International Space Station is orbiting, circling the planet once every 90 minutes, traveling about 17,000 miles per hour. And this is the farthest that people currently travel from Earth. Although 50 years ago, we traveled even farther. We, collectively, humans. 50 years ago, humans traveled about 1,000 times farther than this to our satellite, the moon. Today, of course, is what some people call Moon Day. It is the 53rd anniversary of the Apollo 11 moon landing. So we backed away from the Earth so we can have a look at the space immediately around our planet, and I can see our moon right now. So let me zero in on the moon so we can have a close look at it. The moon being our nearest neighbor in outer space, about 240,000 miles away, a quarter of a million miles, basically. And the moon about 2,000 miles across. It's a huge ball of rock, dry. You can see a lot of interesting things on its surface. In fact, if I turn off the shadowed side of the moon, you can see the whole thing. And the whole surface of the moon is covered by either craters or what are called maria, those dark patches. Those dark patches are actually floodplains of dried lava that flowed out about 1 billion or so years ago, covered over the older surface. And subsequently, you can see a few younger craters have formed on top of the maria since that time. The word maria is from the Latin. It means seas or oceans, and people used to think that these were bodies of water. Today, though, we know that they're not bodies of water at all. They are huge, huge seas of lava, dried lava, forming those rocky plains. That's the moon, our own satellite on Earth. We traveled there 50 years ago during the Apollo mission, the Apollo program, and NASA currently has plans to return to the moon in a program called Artemis, which you can find out more about. And Artemis is a very interesting program. It took the astronauts 3 days to get to the moon, which is a long trip. It took their radio signals, which travel at the speed of light, about 1.5 seconds. And that's something that astronomers like to use, the speed of light, to measure distances in outer space. So if we could travel at the speed of light, which is 186,000 miles per second, you could travel from Earth to the moon in 1.5 seconds. If you could travel 186,000 miles per second. You could travel around the world 7 times in 1 second. You could travel from the Earth to our nearest star, the Sun, in about 8 minutes. So if we travel far enough away from the Earth, we'll see where it is in the solar system, and we'll see the moon appearing at the bottom of our screen there. Our star, 93 million miles away. You would be able to get there in 8.5 minutes if you could travel at the speed of light. Another way of putting that is that if the sun were to suddenly turn off all of a sudden, it won't, But if it did, you wouldn't know it for another 8.5 minutes, because that's how long the light leaving the sun right now would take to get to our eyes here on Earth. Let's take a little quick survey of our solar system. The nearest planet to the sun is Mercury, the smallest of the planets. Next comes Venus, very brilliant planet. Third is Earth. We're on the Earth, the third rock from the sun. Fourth comes the red planet Mars. And then after Mars, there's a gap, a big empty space. That is not really an empty space. It's an area filled with chunks of rock and rubble and debris left over from the formation of the solar system, called the asteroid belt. But not all the asteroids are just stuck there in the orbits just beyond Mars. There are some that travel in close through the inner solar system and some that go farther out beyond. And after the asteroid belt come the giant planets, Jupiter, Saturn, Uranus, and Neptune. These are the giant planets of our solar system, and those are the 8 currently recognized planets orbiting the sun. Now, a lot of people ask, what happened to Pluto? I used to learn that Pluto was a planet. Well, it's still there. Nothing happened to it, but it's now considered a different kind of object because astronomers thought that Pluto might be it's kind of an oddball. It's a small planet, very much smaller than the other planets that just came before it. Jupiter, Saturn, Uranus, and Neptune are giant planets, but Pluto's a dinky little thing. And then if you look at its orbit is very, very strange. Look at the orbits of the other planets in the solar system. They all seem to orbit around on the same plane, like a bunch of marbles on the same tabletop. But Pluto's orbit is highly inclined or tilted. And that suggests to some astronomers that maybe Pluto has a different kind of origin that we should be talking about. Maybe it is just a different kind of object. And so they decided to rename it and call it something else, a different kind of planet. It's called a dwarf planet. And there are 4 other dwarf planets in our solar system, but it's no longer considered a major planet like the other big guys. One other thing I want to show to you is another region of debris that's outside the orbit of Neptune. It's kind of like the asteroid belt, but a lot messier. This is called the Kuiper belt, or the zone of trans-Neptunian objects, which is all of this. Now, these are largely comets and other dwarf planets, like Pluto. And there's just a mess. There's all kinds of stuff. Their orbits are all over the place, but there's a lot of stuff out here. And this is one of the reasons why scientists decided that Pluto is not a planet in the sense like Jupiter, Mars, or Earth. Because in their definition, a planet has to use its gravity to shove other objects out of its way and kind of bully its orbit clear of everything. And Pluto clearly has not done that. So that's the Kuiper belt, which is one definition of the outer edge of our solar system. There are other definitions, though. One other thing that I'd like to show you is are the farthest that our spacecraft have traveled away from Earth. Now, back in 1973, we started launching spacecraft toward the outer solar system and beyond. And there are 5 that have since gone that far. The one going off all by itself over to the left is Pioneer 10, which was launched back in 1973. And then Pioneer 11, which followed it, is one of these traveling off in the other direction. The farthest spacecraft that has traveled from Earth is Voyager 1, which has the longest path. And that spacecraft has traveled about 17 billion miles away from Earth in the past 44 years. It was launched back in 1977, and it's taken 44 years for it to get way out here. The other spacecraft are Voyager 2, which took a downward turn after Neptune, and then New Horizons, which has the shortest path there. That's the one that went by Pluto just a number of years ago. But let's travel on. Let's move on from our solar system and see how much farther out we can get. You know, we still have not reached the end of human influence in outer space. We've seen the space station. We've talked about the moon and the Apollo program. We've talked about our spacecraft like Voyager and Pioneer and how far out they've traveled. But there's still something else that is an artifact of human civilization, which has traveled farther out, even beyond the stars. And that is our radio signals. For about the past 90 years, our radio signals have been radiating out into space. And by this time, they form sort of a bubble around our planet, indicating our presence in the universe. This is as far as our radio signals have traveled through the universe. And it looks big, and it encompasses a number of stars, but it actually is quite small compared to the rest of the universe. But notice that there's some stars inside the radiosphere. If there were any civilizations on planets orbiting those stars, they might have heard our radio signals. On the other hand, the other stars that are outside, well, our signals haven't reached them yet. If there are any civilizations out here, outside the radiosphere, they wouldn't know about us yet. They haven't heard our signals. A really interesting thing to think about. And if we travel farther and farther out, we'll see how big the radiosphere is compared to our own galaxy. About 100 years ago, astronomers thought there was only one galaxy in the entire universe. But then Edwin Hubble showed them that there are other galaxies. The universe is a lot bigger than astronomers used to think. And here's the radiosphere. You see it? Right there along the edge of one of the spiral arms. And that's how tiny it is compared to our own galaxy. The Milky Way galaxy is a huge flat disk of several 100 billion stars, of which our sun is only one. It's about 100,000 light years across. So at the speed of light, it would still take 100,000 years to get from one edge of the galaxy all the way across to the other. So it's 100,000 light years across. And we are not at the center. We're off along one of these spiral arms, as you can see there. Now, the Milky Way is, again, not the only galaxy in the universe. It's actually part of a small cluster of galaxies called the Local Group, which at last count contains about 80 or so galaxies. And we're going to see now that since we're outside the galaxy, every spot of light that you see on the dome overhead is not a star, but a galaxy. And this is all based on actual surveys of the sky. So this is real data showing us where galaxies are with respect to each other. So our Milky Way is one member of the Local Group, but there are lots of other clusters out there too. And they've been surveyed over the past couple of decades. And we can see that galaxies are clustered into huge clumps, as we can see, clusters or superclusters. Those are clusters of galaxies. And some of these clusters contain thousands of members. And some of them are clumped together, separated by huge voids or empty spaces. And the different colors that you see here they just indicate the particular survey that took note of these galaxies. The galaxies aren't really multicolored like this, although it'd be kind of cool. But let's travel farther out, and we'll see something really unusual about the structure of the universe, at least as far as our map indicates. This is all the data that we have collected about the distribution of galaxies in the universe. And this is what we've got so far. And you can see that the universe, our model of the universe, seems to have a rather unusual shape, doesn't it? It looks like a big butterfly or even a big hourglass. Is that the real shape of the universe? Well, no, it's not. This is the shape of our model only because this area here is not empty space. This is actually just areas where we haven't collected too much data. We haven't gotten enough information yet to say what's out there. We're beginning to, and that's what this purplish plane of galaxies is indicating. But gradually we will find out more and more about what's out there. But this is just the current state of our model of the universe. We expect it to be more uniform, and we expect to fill out more of this. Speaking of galaxy clusters and looking out into the universe, let me show you something that was just released last week, and that is one of the first images released from the James Webb Space Telescope. This is the deepest infrared view of the universe, looking at the heat of distant stars and galaxies. This was the first image released from the James Webb Space Telescope. They say it's got about another 20 years ahead of it. So imagine what we're going to see during the next 20 years. What this picture shows is a cluster of galaxies that was taken with the southern massive compact survey, and that cluster is about 5 billion light years away. 5 billion light years away. But its gravity, its mass, is causing its gravity to bend the light of other galaxies behind it. And the light of those galaxies gets warped into these arcs, which you see here, the reddish colored arcs, which are far more distant than that galaxy cluster that's doing the bending. So that's what's going on in that picture. And the bright, spiky object you see there is a star in our own galaxy. And that's one way that you'll be able to tell pictures taken from the James Webb Space Telescope. It has that 8 spikes. There's a faint one going horizontally across, but there are 8 spikes in James Webb images as opposed to, say, 4 spikes in the Hubble Space Telescope images. So next time you see a picture from outer space, count the spikes around the star images, and that'll tell you what telescope took it. Let's move on. Traveling even farther out, we come now to some of the most distant objects that have yet been observed, and those are quasars. The quasars are very, very energetic cores of young newborn galaxies. So far away, they're marked by those orange spots at the ends of the fans. Those are roughly 10 billion light years away. And to be as bright as they are at the distances we see them, they have to be tremendously energetic. Some of the most distant things we've recorded. But the most distant thing that has been observed is this faint microwave radiation surrounding everything, permeating the entire universe, coming from all directions. It was first predicted back in 1948 and detected around in the 60s. And this is believed to be basically the first light in the universe that was able to travel from one place to another. At one time, the universe was so hot, so dense, so opaque, light couldn't go anywhere. But about 300,000 years after the expansion of the universe began, a time that some astronomers called the Big Bang, then light began to penetrate the universe and able to travel from one place to another. And that's the light that we see in the cosmic microwave background. That's the best evidence that astronomers say there is for the Big Bang, which took place about 13.8 billion years ago. And since that's as far out as we can go, we've got no place left to go but back toward the center of our model. And I have to say, as we travel to the center of our model, we're not traveling to the center of the universe. It may look as if we're at the center of the universe, and I know some people who think they are, but this is actually just an effect of perspective. It's the result of the fact that we made this map, we made this model. So everything is based on our point of view. If somebody in some other part of the universe made their own model of the universe, it would probably look the same, only centered on them. So just a matter of perspective. As we travel back through the clusters and superclusters of galaxies, note that what do we see? Only amounts to about 4% of the universe. Because astronomers say that they've looked at the motions of galaxies out there, and the motions they see cannot be accounted for by the mass of the everything else that we can see. So there's something else there, making up about 95% of the mass of the universe that's causing galaxies to move the way we see them, but we can't see it. And so that's called dark mass, or dark matter, or dark energy. So most of the universe is something we can't see. Coming back in toward the radiosphere, close to home, you might wonder, we've seen so many galaxies, so many stars. Are there other planets out there? And the answer to that question is yes. Since 1994, astronomers have been detecting planets orbiting other stars. And currently, the count of known extrasolar planets, as they're called, or exoplanets, stands at more than 5,000. Of those 5,000 planets, are there any that are all at all like the Earth? We really don't know, because they're so far away, we just don't know that much about them. But we're gradually learning more and more and more, and things like the Hubble Space, or rather the James Webb Space Telescope, is hoped to help us learn more about distant planets. But you need a number of things. You need the right kind of planet, you need the right kind of star, the planet has to be the right distance from the star, it's got to have the other components that can provide the nutrients that life would need before we can say anything at all about whether or not the planet might be able to support life. So as we return back home to the inner solar system, we find that in our travels through the universe, of all the planets and stars that we've seen, there is really only one planet that has the kind of environment that can support life as we know it, and that is our own home planet, the Earth. So we've traveled 13.8 billion light years away from home to travel back to find that there is, in fact, no place like home. Our own planet, a very unique and fragile place where life exists in a very delicate balance with its environment. That means that our planet is a very, very delicate and fragile place that we need to take really good care of. And that's what the Academy of Sciences is all about learning about biodiversity and learning about our planet and habitability. And hopefully we can all take that lesson away with us and be better stewards for our planet. And with that, welcome home. Welcome back to the planet Earth. And we thank you all very much for joining us on our tour of the universe.